Okay, let us start. So do you have any kind of questions? If you have questions, please ask. Aditi, do you have any question?
No, sir.
Okay. Any questions from the student side? Chandan Kumar? Chandan? Chandan Kumar? Oh, Chandan Kumar is not here. So, forget about that. Lovepreet? I asked Lovepreet.
No, sir. No, sir.
Huh? Yeah.
Sir, no
Lovepreet,
doubt.
do you have any question? Okay.
No,
doubt.
sir.
Okay. Let us start. I'm presenting the slides. Is it visible? Oh my God.
Yes, sir.
Yes, sir. Today I am going to discuss about that it has cut. This one has cut.
Yes, sir.
This one has cut. Okay. However, I don't know. I have to print it again or not. Matrix. What is matrix? Matrix is a two-dimensional array. We have seen that two-dimensional array is also a single-dimensional array. So in the single-dimensional array, we do what? We do logically represent a single-dimensional array as a two-dimensional array. It is just converted into two-dimensional array in logically. So in this case, we have seen that what is matrix, and we know what is matrix. So in class 12, we have read that what is matrix, but how to program with matrix. So it's a definition. A matrix is a two-dimensional data object made of m rows and n columns, therefore having total number of m into n values. So to print a matrix, it takes big O m into n time complexity. So how will it happen? We'll discuss it later. So this applications is the applications of matrix is that image processing, video processing. Oh, somebody else. Sorry. Maumita Chaudhary, so late request. So, image processing, video processing, speech processing, signal processing, Facebook friends, Twitter tweets, recommendation engine, etc. So these are other applications of a matrix. So what is an image? Image is nothing but a numbers, a 2D matrix. And video is a set of 2D matrix. And species again 2D matrix. Signal processing, any kind of signal is also a 2D matrix. Facebook friend, Twitter, recommendation engine, everything is a 2D matrix. So for example, we are so for example, if we are talking about that Facebook friend or image or signal processing, say for example brainwave processing. So brainwave processing, what is brainwave processing? Brain will generate some signals, brain will generate some signals, and that receiver will receive the signals, and this receiver signals will be stored, captured in the form of 2D array. And say for example, my speech, this sound is captured by this receiver, and it is captured in the form of 2D array. Okay, so this is a matrix. Okay, so for example, there is huge applications of matrices. That's why only matrix, for matrix there is a laboratory, there is a software, lots of software regarding matrix, lots of tricky things can be done in matrix. So here, what are the softwares and famous software? The most famous software is Matrix, MathWork. I have not written here MathWork, and Octave, OpenCV, Simulink, LabVIEW. These all those kind of softwares. What they do, they perform a matrix operations. Some operations may be rotation, maybe multiplication, maybe some other operation. They perform some operation efficiently. That's why this say for example, that's why this matrix laboratory, Simulink, OpenLab, OpenCV, MathWork, and lots of that kind of softwares are available to perform matrix, that one. So whenever you will going to do, you will work on the matrix in a future life. Okay, you will work on matrix. So we have to understand how matrix works, how to represent matrix, and what are the matrix. So we have to 2D array, actually 2D array, maybe 3D array, maybe 4D array. You may work on 3D array, or you may work on 4D array in future, 3D image processing, or 3D 4D image processing, or maybe 3D signal processing. Some kind of opportunity will come to your life, and you may work on that. But ultimately, what is this matrix? What is this matrix? These matrices are nothing but these are, so what? These are two-dimensional array. It is converted to two-dimensional, three-dimensional, four-dimensional array logically using few mathematical calculations. So now let us start with the problem. What is a problem? Problem is that write a program to rotate an image or a matrix in 90-degree angle. Okay, so image is nothing but an, what is an image? Image is nothing but a matrix. So or matrix, or that matrix contains some numbers of in the image, so that is known as matrix. So or that is known as image. Say for example, a football playing image, you could have a cricket playing image, basketball playing images, some other images. So this is image. You would like to rotate in the 90-degree and 90-degree angle counterclockwise, some other direction, or maybe you would distort this matrix, or you would like to edit this matrix. You would like to copyright, say for example, if you would like to add some watermarking on this matrix, or if you would like to know that whether this forensic purposes, whether this matrix is matrix has been whether this matrix has been modified or damaged by some other sources while transmitting, then you can check that integrity of the images. Say for example, blind forgery detection, whether this matrix has been forged or not. You can check. You can always check. These are the lots of problems, lots of thousands of problems in matrix. Huge problem in matrix. Say for example, boys will be very happy when they will be working on that. Say for example, F22 Raptor. Then their that IR signature or heat sink signature capture some metrics and working on that. Say for example, another amka boys will be very happy while capturing that from camera. They will capture the amka will capture the camera, some scene, some shot or some images. Then you will going to work on that, then you will be very happy. And you will be very happy in working on that. Maybe in the missiles, say for example, brahmos is scanning here and there, and it's high performance that computing machine process the process the what process the images or process the metrics very quickly. Okay, so this is what about the metrics. So say for example, for girls, they will be very happy in drawing flowers or some other else. Say for example, if they have seen that photo of Sushant Singh Rajput. Okay, they have seen Sushant Singh Rajput, and then whether this is murdered or not, if they are going to investigate, then in the photo, this photo is forged or not, they can obviously love to work on that. So this is metrics. Huge problem in metrics. So it's just one problem. Do you know about what is matrix addition, multiplication, and subtraction?
Yes, sir.
Am I audible? Are you listening?
Yes, sir.
Yes, sir.
Yes, sir.
So,
Sir.
Yes, sir.
so you know,
Yes, sir.
yeah, you know
Yes, sir.
about matrix
Yes, sir.
multiplication.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
When
Yes, sir.
Yes, sir.
it is taught in that C programming language, is it? So
Yes, sir.
that's why I have skipped this matrix addition, multiplication, subtraction. So I have just started from this and 90-degree angle. So rotate this 90-degree angle. So how will you going to rotate? Then this entire representation, how will you going to represent this matrix? So this matrix, this position of this 1 is 0 0, 2 is 0 1, 3 is 0 2, 4 is 0 3. Similarly, 5 is 1 0, 9 is 2 0, 13 is 3 0, and 6 is 1 1, 1 0, 1 0 is 2 1, 1 4 is 14 is 3 1. So this is the position. This is the position of the matrix. Say for example 0 0 0 1 0 2. The 0 means the row number, and this means column number. Say for example this means column number. This one is column number. This one is column number. This one is column number, and this one is column number. This is what column number. In representation, we represent column here and row number here. This is the row number. So row identity and column identity. Okay. So we represent like that. So how are you going to transpose this matrix? So matrix transpose. This is a matrix transpose. So matrix transpose is that you have to bring 4 to here, 1 to here, 13 to here, 16 to here. So this is for this row become column of the first and with reverse direction. 4 3 2 1 here. 4 3 2 1. So this is that 4 3 2 1 in this direction, and this is in this direction, and this is the direction of this. So here similarly the same thing. Here 5, 6, 7, 8, 8, 7, 6, 5, 8, 7, 6, 5. Okay, 9, 10, 11, 12. So 12, from this 12, 11, 10, 9, 12, 11, 10, 9, and 16 this in the reverse direction. You have to traverse the reverse direction. When you read from here to there, you can traverse in the reverse direction. So you can easily traverse in the reverse direction 16, 15, 14, 13. So 16, 14. How are you going to solve this problem? This is very easy, right? So it's just you will going to just take an extra array of size n into n and copy accordingly. So B, what will you do? This is an original matrix. This is a the duplicate matrix, and this is known as, say for example, A. I have copied this matrix B. So this in this B matrix, I'll copy 4 here, then 3 here, 2 here, 1 here, similarly like this. And what will be the extra space complexity? Extra space complexity is the B. So here, what is the extra space complexity? Extra space complexity is the B array is the extra space complexity. So what is the extra space complexity? If B is n into n, then we got n square. Otherwise, if B is m into n, then what will happen? M. Okay, just multiplication. M into n multiply, because this is m row and n column. Number of column is n. Okay, so this much of extra space has to be used. So if you see that this is, say for example, row is n, column is n, then n into n square, if it is square matrix.
Excuse me, sir.
Yes.
So in question you have written that we have to rotate matrix in 90-degree clockwise. But the example that you have shown in A and B is rotated anti-clockwise.
Then you do it clockwise.
Okay, sir. No, sir, I was confused, like in clockwise, how?
I have done in anti-clockwise. You done in clockwise. It should be anti-clockwise. Okay. So what is your name?
Sir, Tasneem Kaushal.
Huh?
Tasneem Kaushal.
Okay. So this is it clear, that one, time complexity, space complexity?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So the space complexity is this extra space. You have to take extra space of this. So is less than n I plus plus. So this is I from 0 to n. N is the number of row, and we have taken n again. That means number of column is again n. That is n into n matrix. If it is n into n matrix, then we will take b of ki equal to a of ij, as I have said. So how will you going to solve this in this is counterclockwise, right? If clockwise direction, what will be this be ki, or so this for loop will going to change. Okay, so this is very simple thing. Okay, just need to change the for loop and need to change the ordering of that number. This will be, so what, 1 2 3 4. Okay, 1, 2, 3, 4. Then it's a transpose, just transpose. Okay. So now question is that without taking extra spaces, that is in place solution. If you take extra spaces, okay, then solution is this. Very easy. I just copy the all things to another extra matrix. But the problem is here, without it, a question gives that without taking extra space. That means what is in place solution? In place solution here. What is in place solution? In place solution is that without taking any extra space. Extra space means what? You should not use any variable size of spaces. Say for example, temp equal to in temp. You can take in temp, in n, in I, j, k, l, m, n, o, p. Like this, you can use constant space. You can use, but you cannot use that variable spaces in the in place solution. So in place solution means you cannot take this extra space. You have to do within this given spaces. Within this given spaces means that known as in place solution. So this space means this is random access memory. So I have forgot to mention this, that just I have copied all those this code and these all those things are copied from gigs for gigs. Okay, these are all those things. Everything
Okay.
I have just copied from gigs for gig. I forgot to mention this. Okay, I have just copied from gigs for gigs. Okay, so here if you see that if you see gigs for gigs, you will find this program in place solution program. Then you will going you can understand there is a comment here inside a line to line comment in the gigs for gigs. You can understand using that line to line comments. Okay, now for I equal to 0, I is less than sorry, x is less than x equal to 0, x is less than n by 2, x plus plus. So I am using this temporary. This is another temporary. That memory size should not be variable. This memory size should not be variable. First, what will I do? I copy this I into temp. First, I'll copy this I, this one into this from this one into temp. Okay, then you can copy this one, this 4 into this 4. This is the 4. Sorry. You can copy this 4. You can copy this 4 here. Okay, so 4 will be here. I'm writing here. 4 will be here. Then 1 will be here. This 13 will be here, and this 16 will be placed here. Like this, you have to rotate the matrix in counterclockwise. Okay, in the loop, you see x equal to 0, x is less than n by 2. So this way you need to move only half. Within the half you can complete. So y equal to x, y is less than, what is x here at the very beginning? What is x here? Here x is at the very beginning 0. Okay, so n is here 3. 3 minus x, 0 minus 1. Yeah, sorry. What is n? N is 4. 4 minus x. X is 0. 4 minus 0 minus 1. It becomes 3. So y plus plus. So if condition is true, y is 0. So condition is true. Matrix of this 0 0. I will keep the 0 0 equal to temp here. Temp equal to here, and math of 0 0. So in the math of 0 0, what will I do? I'll copy math of 0. Y is 0. Y is 0. What is n minus 1 minus x? That means it is 3. 0 3. That means what is this value? That is 4. So math of, I'll copy y is 0 here, y is 0 here. What is n? N is 3 minus 1 n is 4 minus 1 minus 0. That means it is 3. At the place of 0 3. Where is the 0 3 here? This is the 0 3 here. At the place of 0 3, what will I do? I do here math n minus 1 minus x. What is n minus 1 minus x? It is 3. Again, n minus 1 minus y. N is 3, n is 4 minus 1, that is 3 minus 0. Y is 0. Here initially 0. Then it become again 3. What is that? What is that? That is 16. A matrix of 3 3 is a 16. Next, here math of here, that means we have calculated here what is n minus 1 minus x. N is 4 minus 1 minus 0 is 3, and 4 minus 1 minus y. That means 4 minus 1 minus 0 is again 3. In the place, we will do what? We will write n minus 1 minus 0. That means 4 minus 1 minus 0. That is math of 3. What is the value of x? Value of x is 0. What is the value? That is, what is the value? Value is the 13. So what will I do? In the place of n minus 1 minus y x and n minus math, n minus y minus x, so 3, it is 3, n is 4 minus 1 minus y, it is 4 minus 1 minus 0, it is 3, and x is 0, equal to temp. What was the temp? Temp was 1. So now I have copied in the math 0 0 plus, math 0 0 plus 4, math 0 3 plus, math 0 3 plus. What is the 0 3? 0 3 is here in the 0 3 plus. What I'll copy? 3 3. 3 3 was 6. So I'll copy math 3 3. Math 3 3. Then math 3 3 is that this place. In this place, I'll copy the value of 3 0. That means 13 will be copied here. 13 is copied here, and in the 3 0 plus, I'll copy 0 0 plus. So this is the in plus rotation. So next iteration, x equal to y equal to y become 1. So y initially 0. So here x will remain same. X will remain 0, but y will increase, and accordingly you will repeat the loop again. Then you will get this. You will get this result. Okay. So this is in place. This is in place This is in place sorting. Oh, sorry, this is in place rotating. Okay, so now in the next problem, this is the next problem. Write a program to print a matrix spirally. Spirally means this round and round, round and round, this spiral. So I have taken this again from this figure again from that gigs for gigs. This is nicely drawn. So first you will print, this is the matrix 4 into 4 matrix, but how are you going to print? First print 1, then 2, then 3, then 4, then 8, then 12, then 16, then 15, then 14, then 13, then 9, then 5, then 6, then this spiral. This is the spiral. So what will be the output? Output 1, 2, 3, 4, 8, 12, 8, 12, 16, then 15, 14, 13, 9, 5, 6, 7, 11, 10. So this should be the output. So how are you going to do this? And this code is also taken from gigs for gigs. So it's print spirally. So this, if you print spirally, so I, comma k, comma j, this could you are first you have to first print this row. This is for this row, this direction. So this direction. So this is for this direction, and this is for, so what, n minus 1. N minus 1 is fixed. It is not variable. I is variable. That means we are varying this. Row is varying, but column is fixed. And again this row is fixed, but column is varying. This. Again this, both are varying. So this way. So in this case we have seen that kj, this will vary, k and j will vary in this direction, but here n will be fixed. That column side, column, this is the column will be fixed, row will vary. Then we will move downwards. Okay, we will move downwards. Then k, here row will be fixed. This row will be fixed, and I will be varying. That means I will be decrementing from the end point. So from the right to left, it is decrementing. The column is decrementing from the left to right side, and then I and L, column, row and column is decrementing here. Both are decrementing. So k will be also decrement. I will be also decrementing, and sorry, column will be fixed here. Column will be fixed. So this is the zeroth column. Next column will be that. If you move this side, then next column will be the second column. So column will be fixed here. So for today, okay, for today. So do you have any question? So time complexity. What is the time complexity? I forgot to mention about the time complexity here. What is the time complexity here? So let me explain what is the time complexity. Time complexity is big O n divided by 2 into big O n is equal to big O n square 2 divided by 2, which is equal to big O 1 divided by 2 into big O n square, which is equal to big O n square. So here that the time complexity again we got n square. Okay, now in the next slide, in the next spirally, okay, spirally. So how many elements are there? There are m into n or n into n elements are there. So if it is m into n elements, if it is m into n elements, so you have to print all elements. You have to touch every element. So that's why m into n. Or otherwise, if it is n into n square matrix, then it is we got n square. Because you have to print all the elements. 1, 2, 3. How many will be there? It is n square. So do you have any kind of question today?
Yes, sir.
Yes.
Sir, in the little before you said that we can check if a matrix is altered or not. I really missed that part. What did you say?
What?
You can say that we can. You said that we can check a matrix if it has been tempered or not.
Yes, forgery.
How?
Image,
How can it be,
image
sir?
forgery
I just
detection.
missed that part.
Okay, that is that image forgery detection. Say for example, fake image detection. Okay,
Oh,
fake image detection.
okay.
Say for example, Narendra Modi's photo, and then it's a fake image of that fake image is circulated by opposition. Okay, doing this kind of doing this thing, doing this thing, doing this thing. So doing these bad things, then in politics, that fake image detection can be done in image forgery. Okay, lots of problems are there.
Oh,
Huge problems are there. Okay, so not only that,
okay.
not only that, in the say for example, if you have used power machine set, in a, what will you going to do? What will you going to do? You will write matrix problem. You will solve some matrix problem in, say for example, DRDO lab or ISRO lab or some other labs, or in the real life, in that Google, in that, say for example, you will you will going to handle machine learning. What is machine learning? It is a machine learning that is that uses either tree or matrix. Okay, so normally most of the machine learning uses that one matrices. So if you use machine learning techniques, then recommender engine, okay, but Twitter tweets, Facebook friends, all those things. If you use, then you will going to that one. Say for example, if you won't believe that, let me write. Say for example, this is. This is Azad. Let me note it down. Azad, okay, Aditya, Rahul, and say for example, Sarmishta, two. Okay, it's enough. So Azad, Aditya, Rahul, Sarmishta. Okay. So this is my matrix, relation matrix. So do I have relation? Azad is related with Azad? Yes or no? Yes. So is Azad a friend of Aditya? If yes, that is one, otherwise zero. If Azad a friend of Rahul, if he is Azad is friend of Rahul, then yes, otherwise zero. Say for example, if Azad is friend of Sarmishta, if yes, that is I'll put 1. If Azad is friend of Ritu, then I'll make it 1. Okay. Then again, Aditya is friend of Azad, then I'll keep it 1, otherwise 0. Aditya is related to Aditya himself. Oh yes. Aditya is friend with Rahul. No. So in the real life example, then Aditya is related to that means a friend of Sarmista, yes, and Ritu also. Ritu also, and Rahul is friend to Azad, Aditya, and Rahul himself. Sarmista now, sorry. Ritu, no. So Sarmista is friend of all. Sorry. So this is Facebook friend relation, right? So say for example. Sarmista is related to Sarmista, not Ritu. Okay. Can you see? Can you see?
Yes, sir.
Yes, sir.
Yes, sir.
When you work in the Facebook, then you will have to do such kind of things, analytics things. Like for example, Sarmista is friend of all, Ritu is friend of all. So here you can find that relation, all relation. Azad is related to Azad, okay? Azad is related to Aditya now. Azad is related to Rahul now. Azad is related to Sarmista. So Sarmista is related to Rahul, then Azad is related to Rahul. The transitive property. Lots of properties can be applied here. So this is relations. Okay. So according to this relation, okay, if Sarmista and Ritu is friend, then if Sarmista and Ritu is friend, say for example, let us make it friend. So Sarmista is very interested in murder case of so-called Susan case, not murder case, Susan case. So Susan Singh Rajput case, then Ritu might also interested in Susan Singh Rajput case. So Facebook does what, or Twitter does what? It will recommend to Ritu, not to some other else, if it is not a friend or not a relation. Okay. So in this case, so lots of that matrix relations are there, lots of applications are there in the matrix, and lots of dilemmas are there. So you need to solve in the real life scenario. Okay. So matrix is so important in the real life scenario. So we have to do, and we have to practice lots more and more to work on matrix. Okay. Is it understood?
Yes, sir.
Yes, sir.
Perfect.
Yes, sir.
Yes. Okay.
Yes, sir.
This who tweets what, who is following what, whom. Say Narendra Modi's followers, 2 million followers, matrix of 2 million followers. Can you imagine the matrix of 2 million followers? One single person have 2 million, not 1 billion followers. Donald Trump has 1 billion followers, more than billion followers. Modi has also more than billion followers. Only 1 or 2%. Can you imagine how we going to solve this dilemma? These are the real life problem, motivating problem to work towards that matrix. Actually. Okay, so entire life we will going to work on matrix. Maybe your image, maybe another signal, maybe this signal, or maybe radar signal. Okay, maybe radar signal, maybe a satellite signal, maybe Mangalyaan signal, maybe some other signal. There are many signals in the world you will going to work on, and these signals are represented in which form? The text form. So it is very important to know how to represent matrix, how to compute matrix very well. And see, if you would like to touch all the element, there is no way to this. If it is m into n matrix, then if you want to touch all the element, then the minimum time complexity is big of m into n, minimum time complexity. Okay, if it is n into n, then minimum time complexity of this matrix is big of n square. Okay, is it clear? So do you have any question?
No, sir.
No, sir.
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 Yes, yes.
Hello, sir. Sir, what is the space complexity of the last program, sir? Spider.
Space complexity, right?
Yes,
We
sir.
have taken space complexity means A. A is given array. You have given an array
So the last
It is constant, right?
here.
last spiral, sir.
No space, no. We have printed
The
in
constant.
just print. We are not doing anything.
Okay, sir.
Have we taken any
Okay,
extra
sir.
space? No, no. There is no
No
extra
extra
space.
space.
Okay.
Okay, sir.
If I take B matrix, if it is A matrix, then I take B matrix, then it is an extra space complexity. Okay. Any
Okay,
question? Any question? Please.
No, sir.
No question.
No, sir.
No, sir. Yes, sir.
No, sir.
Okay.
Sir.
Yes. Yes. Do you have question?
Sir, can you just repeat that in-place solution once more, the time complexity?
Oh, time complexity,
Yes,
no?
sir.
Okay, Sarmista.
Yes, sir.
In place? This one. Time complexity. So time complexity, what is, how many time it will iterate? N by 2 times. Okay. So how many times it will iterate? From it 0. So maybe at most n time, but it will also reduce. But I'll assume that at most n time. Okay. So big of n divided by 2 into big of n equal to big of n square divided by 2, which is half of big of n square. Half is constant here. This half is constant here. That's why I have not written. That's why in big O notation that constant is not written. So also I have not written. That's why big O of n square. Am I clear? Say for example, if it is
Yes, sir.
n by 2. Okay. What will be the time complexity? N divided by n square divided by 4. What is 1 divided by 4? Big of n square equal to big of n square. So this is, it become constant. Half is constant. It doesn't matter in the time complexity measurement, because we don't write C in a big O notation or big theta notation or big omega notation. Am I clear? So do you have any question?
No, sir. Sir, the last assignment you gave, do we have to submit it handwritten or can we type it?
Which one?
The Fibonacci assignment.
Yeah, the Fibonacci.
Fibonacci assignment. So what will you going to do in the Fibonacci assignment is, okay, in the Fibonacci assignment, what will you going to do? You will do you will write the code, submit the code, okay, submit the code in the Google Classroom. It's okay, it will be fine. And
Sir,
text cases, yes.
sir, do we have to handwritten submit it handwritten or we can just submit it in typed form?
No, code. You just .c file, right? You
Okay,
submit
sir.
the .c
Okay,
file.
okay, okay, sir.
.c file in that
Okay, sir.
Google Classroom.
Okay, sir.
You need not to type, and I'll execute and test the all test cases.
Okay, sir.
Okay, you test the test cases. Say for example, net Fibonacci number, zeroth Fibonacci number, and less than 0, -1 Fibonacci number. Will you able to that one? That is test cases. -10, -20. This is test cases. Okay, so test cases means what? To test or to validate your program. So what is how are you going to test your program? You will input minus negative number 0, 1, 2, and 100, 200, 300, 500, 1000, and so on. So it is your test cases. So test cases should be, you should test that using these test cases, what is the behavior of the negative numbers. If I input negative numbers, what will be the behavior? How would I handle? That means, say for example, if you have input some mistakenly you have input that negative numbers, okay, negative numbers, that is a -1. So you have to display that this number, Fibonacci number cannot be displayed in negative Fibonacci. So Fibonacci doesn't have negative. So you have to handle nicely. Otherwise, so do you understand that error code in ATM, error code 53? Do you understand?
Denomination is not available. What, sir? Can you repeat?
In ATM, you swipe your card, okay, to withdraw money, then error code 53. Do you understand?
No, sir.
Say
What
service
is
declined or something, I think.
something declined? What is 53? What is 58?
Transaction
59? I don't care. I don't understand. Okay, so
So
if
the
you
denomination
have,
is not available.
yeah, information is not available. Instead of error code 53, that you have not insufficient balance, or your PIN number is incorrect, or your that one your due to network failure, it is not that it is not we are unable to dispense your money, or ATM doesn't have enough balance in the that one due to some code, using the code. So it should be printed like that. How are you going to handle? So this is the test cases, right? So in the test case, maybe some error may be there. So minus, you input minus, or say for example, you input character or some string, some garbage, okay, some empty, or just entering empty. So how are you going to handle? Or minus 4.5, you have entered 4.5. Okay, how are you going to handle 4.5? We don't deal with a Fibonacci number, doesn't deal with 4.5 floating point number. So this kind of message. Say for example, in the pilot, I'm flying. I'm the pilot, and I'm flying that aircraft. So there is some error has occurred. Say for example, AC is not running in the cabin. So error code 93, 95, 96, 97, 98, 2000, 1300, 1400. Who will going to read this code? Instead, you could give that message that this due to this, this is the error, and the error is something like that. Am I clear? So test case is, say for example, why should we care about test case? Say for example, how are you going to test your ATM? Suppose you have built ATM software, okay, and you are the lead of that ATM installation machines and software deployment machines. How are you going to check? How are you going to test? Extreme heat condition, extreme cold condition, okay? And if you put the key like this, what will happen? If you hammer it, what will happen? If you kick the ATM, what will happen? Not only the number, or not only the valid input. Okay, if you slap the monitor, what will happen? If you slap the box, what will happen? Have you tested all those things? So these are the test cases. Actually, these are the test cases done before deploying in the real life. Otherwise, what will happen if you suddenly kick the ATM machine? ATM machine start dispensing all the money to you. Then only one kick or only one slap, only one punch to the keypad will give you the many money. Is it fair? So test cases is very much important, as whenever you write any kind of program, whenever you write that, you need to test every situation. You have to imagine what it could happen and how would I going to handle this situation. So in the laboratory everything okay, but in the real life scenario everything fails. So that's why test cases is very important. Okay.
Hello, sir.
Okay, sir. Thank you.
Hello, sir. Sir,
And
Fibonacci numbers also exist for negative numbers, no, sir? Fibonacci also exists for negative numbers also, sir. Just I saw in Wikipedia.
Test with negative number, test with floating points number, test with character, test with some other. Okay?
Sir, for negative numbers also it exists, sir. No, I saw in Wikipedia. F of
No,
minus
no.
n.
Thank you, sir.
No negative numbers. Huh?
Sir, in Wikipedia it is shown that f of minus n is minus 1 whole power n positive Fibonacci of that number.
Oh, if you want to display, then display.
Wikipedia.
Okay.
Okay, sir.
But your test case should be validated. You first before going to deploy in the real life scenario, you must validate your test cases. Okay.
Sir, till 1000 it is enough, no, sir? If it
No,
satisfies till 1000.
it n. I'll test for n. N may be anything.
Okay, sir. Okay, sir.
Okay. Bye.
Bye, sir.